Alright, welcome to a video for section 3.3 on slope-intercept form of a linear equation. Before we get into what slope-intercept form is, let's make sure we understand what the words slope and intercept mean. Slope is the rise or the vertical change over the run or the horizontal change of a line. So just remember, rise is up and down, run is left and right. So, for example, we can see that in this line here we have, if we can find two nice points, such as this one right here, which is the point 0, 3, and I can also see this point right here, which is the point 5, 0, we can find the slope by making a triangle and then looking at what the rise and the run are. So, let's make a right triangle going from one point to the other. You could also go this way. It doesn't matter, but you don't need to go both ways. Just one is fine. So think about the directions you would go to go from this first point to the second point. So I would go down, and I'm going down 3 spaces. Since it's down, that's a -3. If it was up, it would be a +3. Now let's go to the right, and that's 5 spaces. Right is a positive direction. Left, if we went that way, would be negative. So here are our rise and our run. Our rise is the vertical change, which is this -3. It's not rising, it's falling, but that's okay. And then our run, which is our horizontal change, is the 5. So our slope in this example would be -3 over 5. We would reduce this if possible, but this one does not have, we can't reduce that, so we're done with that. Alright, the next two things you got to know are what intercepts are. There's 2 types of intercepts. First type of intercept is the y-intercept, and then the second type is an x-intercept. So let's first just define what an intercept is. In general, an intercept is the point where a graph crosses an axis, either the x-axis or the y-axis. So, in the case of a y-intercept, the y-intercept is where it's going to cross the y-axis. And we have a special name for this point when we're talking about lines, and that is, we use the letter B to represent the y-intercept. So let's take a look at where our y-intercept is. In fact, we already put it. It's right here. It's where this line crosses the y-axis. Remember, the y-axis goes up and down. So that point is 0, 3. So this is our y-intercept. So similarly, the x-intercept is where the line crosses the x-axis. And so we've marked that point as the point 5, 0 in our example. So our x-intercept is right here. We don't have a special letter that we use for x-intercept. So the slope-intercept form is a way of writing a linear equation that tells us a slope and an intercept. Specifically, the intercept that we're talking about is the y-intercept, not the x-intercept. Okay, and the slope-intercept form of an equation has y all by itself on one side equals, and then we're going to use the letter m, which is going to represent slope, times the x plus b. So the slope is going to be m. So m is the slope. And as we already mentioned, b is a letter we use to represent the y-intercept of a line. So let's go back. So actually, let's write that down first before I forget. Again, b is the y-intercept of the line. It is always the y-intercept. It is never the x-intercept. The x-intercept is nowhere in here at all. We can find it, but it's not obvious like the m and the b. So let's go back up to this line. Actually, let me highlight this, the same color we've been using for y-intercept. Let's go back up to our line here, and let's see if we can figure out what the equation of this line is in slope-intercept form. So to start with, we already found the slope. This is the slope. It's -3/5. That's m. Then the b we also found right here. That 3 is the b. It's where it crosses the y-axis. So the overall answer to this is y equals, and then our slope is -3/5 times x plus b. So notice the y and the x are going to stay y's and x's because those are the inputs and the outputs of the function. So we don't plug anything in for them, at least not when we're writing the equation. If we want to find some more points, we might make a t-table with them. So here's the 3, which was the b, the y-intercept, and m, which is our slope. So to begin with, let's practice finding from the equation of a line what is the slope and what is the y-intercept. Okay, so you want to look for the slope in front of the x. It is the coefficient. It's the number in front of the x that's multiplying it. If you don't see a number here in front of x, then that means that your slope is 1, because we don't write 1 times x. Okay, so I'm going to do A, and then I'm going to have you do B. So looking right here, this is the number in front of x. That is the slope. We can write that as 2, or as rise over run, that would be 2 over 1, which means we're rising 2, running 1. Then the y-intercept is the number that doesn't have an x next to it. It's a constant. It's just either adding, or if it's negative, it'll be subtracting. So right here we have that it's 7. So the y-intercept is 7. We can write just 7, or we can write it as the point 0, 7. So this is where it's going to cross the y-axis. Okay, go ahead and do same type of question for B. Pause the video, give it a try, and then unpause it when you want to try your answer. Okay, let's take a look at the answer. The slope is 3 over 4, which means we're rising 3, running 4. The y-intercept is -1/5, or it's going to cross the y-axis at 0, -1 over 5, if you write it as a point. All right, let's go the other direction now. This time they're giving us some information, and we have to find the write the equation. So this time we're writing the equation of the line, given the slope and the y-intercept. Okay, so here we're given the slope of -4/5. That is your m. And right here they're giving us a point as a y-intercept. This number right here is your b. So just plug it in. So it's y equals m, which is -4/5, times x. Don't forget the x. And I could say plus -2, like this. That's your b. Or you could write it as -4/5 x minus 2. Okay, go ahead and give the second one a try. Okay, so they give us a slope of 7/3. So that is the number that you put in front of the x. It's the coefficient of the x. And then the y-intercept is 0, 8, so 8 is going to be adding after. I've also linked in for your videos something that I want you to play around with, and that is a GeoGebra applet, the one seen here. Okay, and you can sort of experiment with it. You can see the equation of the line as you move the points around. And you can see the calculated rise and run, and also what that does to the y-intercept. And yes, the y-intercept can be decimals, as you can see here. So you can just play with this to kind of get an idea. So you can see you get 0 slopes. If you try to do an undefined slope, you have no equation. In fact, there's no y-intercept in that one. And that's the weird one. It's not really a function anyway. Keep in mind though that this 4 over 8 is not reducing. It would reduce to 1 over 2. So the slope is really going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, which is the same as going up 4 over 8. Just think little steps versus big steps. So please play with this and you can kind of get a better feel for what's going on graphically. Okay, so going back to the notes. In this example, we want to write the equation of the line in slope-intercept form using a graph. So kind of how we did it up here. So some steps that you want to follow. The first thing you want to look for is the b. Find b. So that is the y-intercept. So look along the y-axis. Where does it hit? It hits right here in this example, which is the point negative. So this is at -3. So that is b. The next thing we have to find is the slope. So step 2, in order to find the slope, we are going to find another point, a nice one, no decimals or anything, and make the slope triangle that we looked at before to find the rise and the run. So to find the slope, remember you're looking for the rise over the run. Okay, so in our example here, another nice point might be right here, which is at -2, or even here, or here. There's lots of nice points. So when I say nice points, I mean points that are going to be integer numbers. So anything in the middle of the box is not a nice point. Okay, so rise over run. So we're going to make our triangle. I could do that one, I could do that one. They should all be the same size, so it doesn't matter. It looks like we are going up 1. Since up is a positive direction, I'm going to go +1, and right 2, which is also positive. So my slope here is 1 over 2. Okay, so the equation of the line is going to be, we're going to plug in our m and our b. It's going to be 1/2 x, and then our slope, or the y-intercept, sorry, is, we wrote over it, was -3. Okay, go ahead and try b. Okay, for this one, I can see that the y-intercept is at -1. And then the other 2 points that you want to use, or that are easy to use to find the slope, are right on the edges. The rest of these are not nice points. You have to look very carefully at it. And so you can use either one. If I use this one, I'm going to go down 1, 2, 3, so -3. Right 1, 2, 3, 4, 5. So that would be -3, 5. I want to just show you that if you go this way, you can go up 3, which would be a +3 direction, and left 5 And so in that case it would be a positive 3 over a negative 5. But that is the exact same number as this one. The thing about negatives when you have a fraction, you can put the negative anywhere you want. If you want to put it on the top, or you can even put it in the middle. Those are all the same thing. Okay, last concept we're going to look at is how to take a line and graph it in slope-intercept form. So let's just look at the examples. We have y equals 2/3 x minus 4, and we want to make a graph. So before, what we did was we made a t-table. Remember? Well, we don't have to do that anymore. Slope-intercept form is very easy to graph without a t-table at all. So here are the steps. Start by plotting the y-intercept, which is your b, on the y-axis. Okay, so let's take a look at this first example. My y-intercept is negative 4. So down here, there's going to be a point, negative 4. Remember to do it on the y-axis, not on the x-axis. That is a common error. Next, use the slope, the m, to go to the next point, or you can do this multiple times and get many points. Remember that the top number is your vertical change, which is the rise. The bottom number is the horizontal change, which is the run. If the slope is negative, make sure to go left or down or left. But if you go both, the negatives will cancel out and the slope will turn out to be positive again, not negative. So if you want a negative slope, go down or left, but do not go both. So in general, if you have a positive slope, there's two ways to do it. You can go up and right or left and down. If you have a negative slope, then go down and right or up and left. So notice there's that you either go left or down. But if you go both, you're back up to a positive slope. Then you should have some points, and then you can just go ahead and draw a line. Okay, so our slope here is 2/3. 2/3 is a positive slope. My rise is 2. So this is, since it's your vertical change, and my 3, which is my run. And you're going to count that from the point that we plotted right here, which is the y-intercept. So from here, okay, I can, since it's a positive, I can either go up and right or left and down. So I'll show you, you can go both. I'm going to go up 2, right 3. And then I'm going to put a point right where I landed. And then I could do that again. Okay, I can go up 2, right 3 again, and I can get another point. You don't have to do it for every point, but just to get a couple to get the idea. I could also go, as I mentioned, left and down. So going back from the y-intercept, I can go left 3, down 2. And you see, you land on the same point, or the same line, not the same point. And then you can go ahead and draw a line through your points. And there you go. It's beautiful. Okay. Try this one. So let's take a look at the answer. The y-intercept of this one was 1. So I'll put a point on the y-axis at +1. The slope of this one was +5/3. So I could go up 5, right 3. You could also go down 5, left 3, and you'll land on the same point. Okay, a couple more examples. I'm going to have you try both of these as well, but I just want to point out a couple of things first. For B, when you have a slope that has a whole number, you need to think of it as over 1, because you need to see that rise over run. So this is a -3/1, which we can think of as, well, that's a That's your rise over run. Oops, rise goes on top. Sorry, over run. And so this is a negative slope. So going back up to my tips here, negative slopes, you want to go either down and right or up and left. Okay, so plot your y-intercept of 5, and we can go down 3, right 1. If you try to go up and left, you're going to be off the graph, so I couldn't go that way. So down 3, right 1. And then I can just go ahead and graph the line. And it's going to continue to go down 3, right 1. So when I draw this line, I want to kind of hit those other points, right? Down 3, right 1. Down 3, right 1. Okay, now D, our last one. If you're looking for the y-intercept, and you're wondering where it is, it's there, but think about what number would you add where you wouldn't write it, and that would be 0. So we don't write plus 0. So your y-intercept is at the origin. Okay, so then we just have to use the slope to finish this one. So our slope is negative 3, 2. Notice the negative is in front, in the middle, but you can put it anywhere you want. Doesn't matter. So I'm going to think of this as going down 3, right 2. But I could also think of this as going up 3, left 2. Either one. All right, down 3, right 2. Or I could have gone left 2, or up 3, left 2. And there's our line. All done.